So 1808, John Dalton and the atomic theory of matter. It was nearly 90 years before the next turn of events, and that was the discovery of the electron in 1897 by J.J. Thomson. And before J.J. Thomson did his studies, it was clear that there was an understanding of atomic structure. We have the 1808 atomic theory of matter, but that theory was not complete because as studies evolved, a fundamental question emerged. And that was, how do atoms bond to form molecules? Why do we have carbon monoxide in one case and carbon dioxide in another case? What is it that binds these atoms together? The answer to this came from the discovery of the electron in 1897, and it was the union of the studies of electricity and high voltage that provided the crucial evidence for the existence of the electron. And it was the English physicist J.J. Thomson working with evacuated tubes that contained different gases like hydrogen or argon or neon or helium, to which he applied a high voltage, and the application of that high voltage created the recognition that atoms were divisible. And how did J.J. Thomson come to this conclusion? Well, he came to the conclusion using a cathode ray tube, and this is what he called this tube. And the idea that there were negative charges came from the fact that when he created this tube, he had a negative terminal, the cathode. He had a positive terminal, the anode. He had evacuated this tube so there was a very small amount of neon or argon or some other gas in it. And he applied this high voltage, and he could control that high voltage by adjusting a particular part of that apparatus. And as he increased the voltage applied, at some critical juncture, that tube glowed, and in fact he could see a stream of particles going from the cathode to the anode. This was the first indication that there was something very interesting going on at the atomic level, that the atom wasn't simply a continuum without any subparticles associated with it. Let's take a look at this cathode ray tube for a moment, because it turns out it's very important. The application of high voltage is what leads to this stream of particles leaving the cathode and entering the anode. And it was the systematic application of different tests by J.J. Thomson who determined the behavior of these particles using both electric fields and magnetic fields. And we'll see that both of those are very important, because the electric field is what drove that beam of electrons from the cathode to the anode, but it was magnetic fields that allowed him to look at the curvature in that flow, demonstrating that these particles, which had a charge, also had a mass, because when he applied the magnetic field, he could curve the trajectory of those electrons and determine the charge to mass ratio. So let's see how that works. So Thomson determined with the cathode rays that particles would move in a straight trajectory, that importantly these particles were independent of the material. That is, he could put argon or krypton or neon into this high voltage breakdown, and the particles behaved exactly the same way, and they carried, all of them, a negative charge. But when he applied the magnetic field, he could curve or put in place an arc in the trajectory of those particles and determine the ratio of the charge to the mass of those subatomic particles. And it turns out that the measurement of the charge to mass ratio of these particles was crucial to analyzing what, in fact, they consisted of. So the first thing that Thomson determined was that those particles were 2,000 times less massive than hydrogen, and hydrogen is the lightest atom. And that meant that these charged particles were a tiny, tiny fraction of the actual mass of the atom. But the thing that really rewrote the atomic model was the fact that the atom was divisible. And it was that fact, along with the proven demonstration that these particles were negatively charged, meant that there was some positively charged aspect to that atomic structure that was buried inside, as yet undetermined and undiscovered. So this new subatomic particle discovered by Thomson, he called the electron. So this negatively charged particle that occurred in all atoms now had a name, and many in the scientific community reacted with disbelief. It was the scientific method that finally settled the matter, because it would test these laws against observation. And the cathode ray tube was the basis not only of the discovery of the electron, but also the construction of the first television sets. And we have a diagram of what that cathode ray tube looks like in a television set, because we have an anode and a cathode that accelerates these electrons through two plates, and the application of the electric field can deflect those electrons in any direction that you want, and when it strikes the phosphor-coated tube, it leaves a tiny point of light. And so a television set simply scans that electric field and sweeps through the entire area of that phosphor-coated end of the tube, and that creates a picture, because it can either be dark or light. And of course, as the technology evolved, color television came along, and so controlling the energy of the electron could also control the color. Also, neon signs are exactly the same as J.J. Thomson. So whenever you see a neon sign or some other glowing light that is advertised in the window of a store, you can think of J.J. Thomson and think of the fact that it was exactly that tube that discovered the electron.